All right, so the first thing you want to do when you look at your functions is see if they can be factored and simplified. This one has x squared minus 9 in the top, x minus 3 in the bottom. And so you can factor that to be x plus 3, x minus 3 over x minus 3, which the x minus 3's cancel. That tells you there's a hole, okay? And the hole occurs at whatever the x value is that you're canceling out. So if x minus 3 is the factor that I'm canceling out, then 3 is the value of x in which there's a hole. So I'm going to cancel it out, and what's left is y equals x plus 3. This is a line, right? So when I go to graph it, I graph it as a line. So I would put my y-intercept at 3. My slope is 1. So I go up 1 and over 1 in each direction, and I would have a line that passes through there. However, there's a hole at 3. So wherever the x value is 3, there needs to be a hole because that point is undefined. If I plug 3 into this function, my equation, because it would have been over 0, is undefined at that value. So that's where it gets the hole. And then if you need the exact location, like this time you actually could have counted with your slope, but if it's not that easy, then I needed the y coordinate that matches that. That's this. So I take that x, where the hole is, and I plug it back into the function. And you plug it into the function after you've simplified it because that's what you're graphing. So if I plug 3 in there, I get y equals 3 plus 3 and y equals 6. And that's where this 3, 6 comes from. So I know the exact location of my hole. So then all the other questions you base after you've simplified. There's no asymptotes anymore because there's no vertical. There's no horizontal. There's the hole at 3, 6. Your 0, if I set that equal to 0, is at negative 3. My y-intercept is 0, 3 because I will plug 0 into it. And my domain is all real numbers except for 3, which is negative infinity to 3, union 3 to positive infinity. So everything that's graphed is based on what happens after you simplify. You're welcome. Okay, so in that section it says, find all the zeros of the function, write the polynomial as a product of linear factors, verify your results by using a graphing utility and to graph the function. So for this section, the first thing I would test to see is it factorable? Because there's 4 terms. Okay, if you look at the first one, it's not factorable, right? There, you can't, I can group that. There's nothing I can take out of both of them that's going to cancel out. I can take out like a 6 on the second one, but it doesn't help you. So the next thing you would want to do is test your possibles. So you got to figure out your possibles by doing plus and minus last over first. So because the first is 1, the last is 24, my possibles are 1, 2, 3, 4, 6, 8, 12, and 24. And then from there, you got to figure out what works. Scarface Rule tells me that there's 1, 2, 3 sign changes. So there's 3 or 1 possible positive root, which means positive would be a good place to start. So I'll start with 1 on the outside, 1, negative 7, 18, negative 24. And it doesn't work, so then I'd go to negative 1. Doesn't work, so then I go to positive 2. Doesn't work. Doesn't work. Nope. Doesn't work. And that's the first one that works, right? So 4 is one of my roots. And then I want to take this, x squared minus 3x plus 6, and see if I can factor it. There's no factors of 6 that sum to -3, right? It'd be 1 and 6 and 2 and 3. So this means I have to do quadratic. A would be 1, B would be -3, and C would be 6. So the opposite of -3 is 3, plus and minus the square root of B squared minus 4 times A times C, all over 2 times A. 3 plus and minus 9 minus 24 over 2. And this is I root 15 over 2, because that would just break down in 3 and 5, and that doesn't, nothing repeats, so it stays that way. So when I write them as separate, it'd be 3 halves plus root 15 over 2I, and then 3 halves minus root 15 over 2I. Those are my remaining roots. So that's the first step, is find all the zeros, right? Yep, find the zeros, so 4. And then those 2. And then it says write them as a list of linear factors. So it's x minus 4, x minus 3 halves minus root 15 over 2I, x minus 3 halves plus root 15 over 2I. And then you can't have the fractions. So it's 2x minus 3 minus root 15I, and 2x minus 3 plus root 15I. Which one works? Did you?
Okay, yeah, it's negative.
So it would have been 1, 2, 3, 4, 6, 12, and then 1/3, 4/3, 2/3. Yep. Okay. So which one works?
-6.
Oh, that had to be fun. Okay. -3, 18, -1, 6, 2, -12. Okay.
So this one's factored, but I did quadratic from that anyway, and it still came out the wrong answer.
Okay. So A, -3, B, -1, C 2. Opposite of B plus or minus the square root of B squared.
I did quadratic, but I put the negative. I took the negative out, so it was 3x plus x.
Ah, you can't do that.
Okay. I didn't
So
know.
that's only if it's set equal to 0.
Okay.
You can't do that because it would actually change the values.
So if you wanted to factor, you can do that, but if you don't factor, then you can't change the symbols.
Correct.
But that, yeah. So this is factorable, right? Pretty sure.
Yeah, because -3 times 2 would be -6. Factors of -6 that sum to -1 would be -3 and +2. As long as it has those factors, then it can factor. So you'd get -3x squared minus 3x plus 2x plus 2. And then group it. -3x squared plus 1. Nope. Sorry, make that x. X plus 1. Take out the 2. X plus 1.
On instruction, the bowling team can be dismissed from class at this time. Bowling team dismissed from class at this time. Thank you.
So those should have been your roots, but you could also go from here. So 1 plus and minus the square root of 1.
Yeah, no, this one makes sense.
Okay.
Sure, yeah.
I'm going to keep going just so I finish it. So this is two things. 1 plus 5, which is 6 over 2. 1 minus 5, which is -4. Oh, not 2, sorry.
I put that answer as 1 plus that, like 1 plus minus 5. I don't even know the plus with the phone.
So, I mean, the good thing is on a question like this, it's multiple choice. You're not going to have both those options. Hopefully you catch it. Okay.
What's the multiple choice?
This portion of your, yeah, because that's on the 2, 4, 2, 5. Yeah, 2, 4, 2, 5 is multiple choice. 2, 6, 2, 7 open-ended. So your quiz, again, which is like 2, 5, and 2, 6, no, 2, 4, and 2, 5, is more than half of your test. That's going to be, there's 8 Multiple choice questions worth 7 points apiece. And then there's 2 graphing questions that are worth 22 points apiece. Yeah, I mean, that's the one we went over on Friday. Okay, so 149, this one I didn't even know about. Says sketch the graph of the rational function by hand. As sketching aids, check for intercepts, vertical asymptotes, horizontal asymptotes, slant asymptotes, and holes. Okay, so if I look at 149, and let's go in the order that they, we would typically do this in. I can't simplify that. There's no factoring, right? So I would go to vertical asymptotes. And vertical asymptotes I set the denominator equal to 0. So when I set this equal to 0, I get x squared equals -1. X squared would equal the square root of -1, and there is no such thing. So there's no vertical asymptotes. Then I go to my horizontal asymptotes. So when the exponent in the top is bigger than the one in the bottom, what's true about my horizontal asymptote? There's none, and there would be a slant, right? So there's no horizontal asymptotes. But what I do know is because it's 1 bigger than the bottom, there is a slant asymptote. And I find that by dividing. So I do 2x to the third. I'd have a 0x squared, a 0x, and a 0, all divided by x squared plus 0x plus 1. And then I divide. So I need 2x here. Multiply it times all 3 terms. 2x to the third plus 0x squared plus 2x. Change your signs. These cancel. These cancel. I have a -2x plus 0. As soon as I get to the point that this exponent, which is a 1, is smaller than the one on the outside, I know that's my remainder. So this is my remainder, which with dealing with slant asymptotes, I don't need, right? So I set this equal to y, and that's my slant asymptote. All right, so let's start thinking about what we have already. If I have a y equals 2x, my b is at 0, my slope is up 2 and over 1, up 2 and over 1. Do it as many times as you need. Then I would look for my zeros, right? So I set my numerator equal to 0. 0 equals 2x to the third. Divide both sides by 2. I get 0 equals x to the third. And I get x equals, there'd be 3 zeros, right? 0 with a multiplicity of 3, which tells you what? It's actually going to cross through at 0, right? So it is a point here. It's going to cross through it. Now I got to figure out what happens to the left and to the right of this function. You can also, so we talked about symmetry, right? Like if you look at your function, if I test for symmetry for the y-axis, I do 2 -x to the third over -x squared plus 1, and I get -2x to the third over x squared plus 1. So it's not exactly the same, okay? One of my sinus changes, but not all of it. So that's not going back to normal, right? So it's not symmetric to the y-axis. To test for the origin, I would set this equal to y typically, but if I'm testing for the origin, I do -y. So think about what happens with a negative, right, when a fraction. If we just had one, just the numerator, they would both be negative, right? The rule with either all going back to the same or every sign being opposite is because if I multiplied everything by -1, it would then become the same. So when you're dealing with a fraction, only one of the top or the bottom has to be the negative, because if I multiply everything by -1, on the left-hand side, I'm actually multiplying by like -1 over 1, because that's the same thing. So only one part of my fraction changes. Does that make sense? So I get 2x to the third would equal positive y. Because it goes back to normal, this is symmetric to the origin. So whatever's happening on the left is going to happen opposite that on the right. But let's say you don't even know that. Just plug in some points, right? So I'm going to plug in -1 and see what happens. I'm going to plug in +1 and see what happens. -1 would give me 2 times -1 to the third over -1 squared plus 1. So 2 times -1 over 1 plus 1. -2 over 2, which is -1. Did I do that right? Yeah. So I'm down here. Then I go to the right. Plug in 1. 2 times 1 to the third. 1 squared plus 1. 2. 1 plus 1. +2. Which now the symmetry should make sense. Everything that's happening on the left is going to happen on the right. This is where you get this kind of funky curve that's going to happen somewhat like that. It's going to go down on the left, up on the right, but again, can't hit those asymptotes on the sides, okay? So, I mean, if it's so, like, you don't have any other points, you just keep plugging in points until you figure out what's happening.
Okay, thank you.
You're welcome. Other questions? 127. Okay, so now it says find the domain to determine whether it's continuous and identify any horizontal and vertical asymptotes. So 127 domain, I would set my denominator not equal to 0. The top's obviously not factorable, so nothing's going to cancel. X and X, so factors of negative 18 that sum to negative 3 would be? Negative 6, positive 3. Solve this and it's 6 and negative 3. So X cannot equal 6 and X cannot equal negative 3. That's my domain, so it goes negative infinity to the smaller one, which is negative 3. Union negative 3 to positive 6. Union 6 to positive infinity. The fact that it starts and stops means it's not continuous, right? Continuous would mean that it never stops. So if there's asymptotes, then it is not continuous. And then my vertical asymptote comes from setting these equal to 0. So X would equal 6 and X would equal negative 6 would be my vertical asymptotes. And my horizontal asymptotes, what's the variable in the top? What's it raised to? A 0. So what's true about the relationship between that degree and the bottom degree? The horizontal is y equals 0. Yep, top is smaller than the one on the bottom, and if that's the case, then my horizontal asymptote is y equals 0. So if I wanted to graph it, I'd have something at 1, 2, 3, 1, 2, 3, 4, 5, 6, and here. And then I would see what happens in between the two, and then to the right and to the left. There's no symmetry here because it's like a shifted and it's not squared. So you'd have to figure out what is happening in between. If I set my equation equal to 0, there is no 0. So like 2 equals 0 can never happen, which means it never hits the x-axis. So then I would plug in a point in between negative 3 and positive 6, see what's happening in between, plug in a point to the left of negative 3 and plug in a point to the right of positive 6 and see if my curves go above or below. Other questions? Remember while you're practicing these to use your graphing calculator to check your answers, okay? Again, you're not going to have your calculator, so don't use it to get the answer. But once you get it and you want to confirm it, you could use that instead of CalChat if you want. But CalChat will do the breakdown for you. Everybody's good? Questions? All right, so 139 says, find all the vertical, horizontal, and slant asymptotes, any holes in the graph of the function, then use a graphing utility to verify your result. So let's pretend you don't have your graphing utility because you'd have to work all the way through it without it, right? So the first thing I'm going to do is check to see if I can simplify this because that's what's going to create a hole, right? So positive 4 means that sums to negative 5 means that this would be x minus 4 and x minus 1. And then the denominator is x squared minus 1, so this can factor into x plus 1 and x minus 1. So this time it can simplify, which creates a hole. So I have a hole at 1 because that's what would be the root if my factor is x minus 1. So for the rest of the problem, I'm using f of x equals x minus 4 over x plus 1. That's my graph. That's what I'm going to end up graphing. The only difference is wherever that hole is, I have to make sure I plot that hole. So I have the x value of the hole. In order to find the y value, I have to plug that back in. So I would do y equals 1 minus 4 over 1 plus 1, and I get negative 3 over 2. So my hole is at 1 and negative 3 over 2. Into the simplified. So the only thing you do with the original would be your domain, because that's going to be where your hole is, and to check for holes. Once you simplify it, everything else is done based on your simplified fraction. Which in one case, like in the case that I posted on Friday, it was actually a line. It was super easy to go from there. This one's not as easy. I still got to find my asymptotes. But it's the same concept. Once you reduce it, that's what you're focusing on.
But that's full. How does slant?
This one doesn't have a slant.
Okay. Can you do a slant?
Yeah. So let me just from here, I would say that my vertical asymptote is at x equals -1, right? Because that would be from the denominator. And my, this would be vertical asymptote. And then my horizontal asymptote, because they're both the same degree, is y equals 1/1, which is y equals 1. So I would have a vertical asymptote at x equals -1, a horizontal asymptote at 1. I'd have a hole at 1, -3/2. So down here somewhere there's a hole, which probably tells you your graph is doing this and this, but you would know that by 1, finding your 0, which is at 4. So x is 4, 1, 2, 3, 4. That's a point. And I would plug in a point from back over here, and it would have been above my curve. Does that make sense? Okay.
But you don't have to plug in a point from up there?
Well, this one just said to find it and then graph. But if this was the actual test question, you're going to keep going.
So you got the 4?
I got the 4 from my 0.
Yeah. Would you just grab, pick a number that's above the horizontal asymptote?
I would pick a number that's behind the vertical asymptote. So, like, I know my vertical asymptote's at -1. I would pick, like, -2 and plug it in. So, -2 minus 4 over -2 plus 1. -6 over -1, which is 6. That tells me it's up here. And so my curve goes that way. So you want to point, wait for it. You want to point from each range that's separated out by your vertical asymptote. So if I have one vertical asymptote, I want a point from the left and a point from the right. If my 0 is a point, if my y-intercept's a point, then that's a point. But if I don't have those points, then I have to plug in the additional points.
And those points are going to help you find the curvy thing.
Correct. Yep. It's either happening above or below that horizontal asymptote. And you got to figure out which one. If I had 2 vertical asymptotes, I need a point to the left of the left one, in between them, and to the right. Okay, so slant asymptote. How do you know it has a slant asymptote? Lily?
The highest exponent of the top is bigger than the bottom.
Is 1 bigger, right? So 141 has a slant asymptote. The highest exponent in the numerator is 1 more than the highest exponent in the denominator. Okay, not just bigger, but 1 bigger. It has to be exactly 1 bigger, because think about what a slant asymptote is. It's a line. If I divide a fourth by a squared, I get an x squared. That's a parabola. That's not a line. So now I'm going to take this and I'm going to divide. Can you do synthetic division? Yeah, make it easy on yourself. Put a -1 on the outside. 3, 5, -2. Bring down the 3. Don't write the -1. Bring down the 3. Multiply it times -1. Put it in the next column. Add it. Multiply it by -1. Put it in the next column. Add it. Even though I don't need it, I don't even have to do that part. Okay? What I do need is the rest of it. So the 2 is my constant. The 3 gets the x. My slant is y equals 3x plus 2. I'd have a vertical at x equals -1 and a slant at y equals 3x plus 2. And then I'd have to solve my numerator for my zeros, figure out which way the curves go. Sophia?
Will there ever not be a vertical asymptote?
Sure. One of them doesn't have it. One of the